Welcome to Train Signal. You're watching a lesson on configuring file and disk encryption. Now, when we want to talk about encryption, what we're really talking about here is something called EFS, which stands for the Encrypting File System. Now, why do we need this? Well, as we've already learned, we have this thing called NTFS permissions, and actually I'm going to take it a step further and say we have NTFS permissions. We have share permissions, right? If we're connecting across the network. We also now have something called dynamic access control. So we have access-based enumeration where we have control that way. But here's the deal. All of those various types of built-in security within the operating system is reliant on exactly that, the operating system. Which means that if an attacker was to gain physical access to a hard drive, and then take it to a non-Windows environment, well, the Windows-based permissions would be useless. Using EFS simply adds an extra layer of protection by encrypting the data on the disk itself, and therefore the files that have been encrypted using this EFS are unreadable in other operating environments. Now, EFS has been around since Windows 2000, and I will tell you that it works so well that there's been very little that has been changed on it since it was first put into place. So I will tell you going in, if you have worked with EFS before, well, then you probably are completely familiar with it, because it really hasn't changed. But if you haven't, or even if you have but you never really understood how it works, let me see if I can really kind of give you the full explanation about how this process works. And I will tell you, some people work with EFS in the sense that they go in to the operating system and they check a box. You'll see when we go in to actually demo it, we're just checking a box, and by checking that box, boom, it's encrypted. Okay, there's not a ton that we do with it. But a lot of those people who know how to check the box don't necessarily know why it's working. So I'm going to give you some of the why here. Now, in order for you to understand EFS, you have to first understand the basics of something called cryptography. Now, cryptography is the concept of applying an algorithm to plain text, right? We just have regular old plain text, and we apply an algorithm to it to convert it into something called ciphertext, and this would be the encrypted text. So here's an example. The example is that if we have an algorithm that says go up 2 letters, right? That's the formula, the algorithm. That just go up 2 letters. Well, if we took the 2 words train signal, and I am going to distinguish here, by the way, that I'm using 2 words, train signal, as opposed to the company that I work for, which is 1 word, train signal. Just thought I'd throw that out there and show you how it's kind of cool. Multiple purposes for those different words. If we take those 2 words, train signal, and we say go up 2 letters, well, then let's look at this. The letter T in train, if we go up 2 letters, we do the alphabet, we'd go up 1 letter to the letter U, up 1 more letter to the letter V. So T becomes V, R becomes T, A becomes C, I becomes K, N becomes P, and so on and so forth. So that you'll see that the 2 words train signal become the 2 words I think that's unpronounceable, by the way. That's VTCKP. And signal becomes UPICN, which is UKIPCN. Did you ever do that when you were back in school? Right? Did you ever have an agreement with a friend and you say, hey, we're gonna go ahead and pass notes to each other, but in case someone else accidentally gets the note, whether a teacher gets it, or maybe we're talking about us boys, we were passing notes about the girls that we like, and it was at a young age where we weren't supposed to like girls yet, and so in case the girl was to get a hold of it, or someone else, we didn't want them to know what we were saying in the note. So we had our own little secret formula, and it might be something like this, to go up 2 letters so that it would be unreadable. Now here's the thing about the algorithms. Most of the algorithms themselves are publicly known. In other words, the formulas themselves are publicly known. So the idea of saying a formula says go up 2 letters Everybody knows that that's a formula that we use. The way we keep the algorithm secure is by adding the use of something called a key. And a key is then a variable in the algorithm. So the example here is that the algorithm is not go up 2 letters. The algorithm is go up X letters. Okay? Meaning that's a fairly well-known algorithm. We all know, if we go back to that story of childhood, passing notes in school, it's not an uncommon algorithm to say, hey, let's write a note to each other, but the letters we'll use will be a certain number of letters away from the actual letters that we were intending on using. Right? So the algorithm is go up X letters. The key is then that variable, is X. So if the key was 2, or in other words, X is 2, then again, just like we saw before, train signal becomes VT, CKP, UKI, But if X was 5, well, that changes the ciphertext altogether. Now the ciphertext for train signal becomes YWFNS, XNL, SFQ. So the way things stay secure is you may have heard something out there. You hear people talk about 128-bit encryption, 256-bit encryption. Well, what that means is the key. The key that is used is a 128-bit key or a 256-bit key. That's what we're talking about. And the longer that key is, right, or I should say the bigger the key is. In other words, the more bits that are in it. Right? And the bits are, these keys are all in 1s and 0s. It's all about binary. The more there are, the harder it is to guess what that key might be. And so that's how cryptography works, just in its most basic format. Now EFS, right, if we reel this back into what this all means about encrypting file system, EFS uses 2 different types of encryption. It uses one thing that's called symmetric key encryption, which means that the same key is used to both encrypt and decrypt the data. Okay, so you have one key, and the example of symmetric key encryption is kind of like what we were just using in the example with the basic cryptography, right? Meaning, if I know the key is go up 2 letters, then I know that to decrypt, all I do is reverse the algorithm with the same key, right? If the key is 2, I just reverse the algorithm and say go back 2 letters. The other type of encryption that is also out there and is used by EFS is something called public key encryption, or what is a form of asymmetric encryption. And this uses something called key pairing. This is where you have keys put out there in pairs, and in each set, right, in each paired set of keys, one key would be used to encrypt, and a different key, the other paired key in the set, is used to decrypt the data. Feeling confused yet? Because this is very confusing to a lot of people. So if you're feeling confused, you're not alone, but don't stop listening yet. Stick with me here. I think I'm going to bring some clarity to this, and definitely if you watch this a second time, it should start to make sense. Let's talk about this public key encryption, okay? Because this is the one that confuses people. And I'm going to tell you going in that if you have any prior training, you will know that I'm not necessarily being overly literal or technologically accurate, right down to every minuscule detail. I'm going to try to keep this very vague and very generic so that you can understand it. So if we said we had a network of, we have our GlobalMantics network. Every user on the GlobalMantics network has a pair of keys assigned to them if we are using public key encryption. Okay, so every single user has 2 keys assigned to them. One of those 2 keys is known as the private key and is only accessible to that individual user. Now, the way I used to illustrate this in the classroom, if you were standing in front of me right now, I would show you that I would have one key in my hand and I would stick it in my pocket, right, where only I can get access to it. It's my private key. Only I get it. But the other key in the key pairing is what's known as the public key. And this key, although it is, it's got my name on it, it is available to everybody. Okay, it is publicly accessible. It's sitting, again, the illustration that I use is it's in a box hanging on the wall where everybody can get to it. Okay, so one key with my name on it is my private key. It's in my pocket. The other one's hanging on a box on the wall. Everybody can get to it. All right, so stick with me here. Right, everybody has these two keys. So let's use an example and see now how this starts to come together. If there were 100 users on our network, there would be 200 total keys, right? Meaning every user has two keys. 100 of those keys would be private and would be in the pockets of each of the 100 individuals. And the other 100 keys would be sitting in that box on the wall. And everybody can get access to those 100 keys. Which means that each user has access to a grand total of 101 keys. Right? Each user can access all 100 keys in the box on the wall, and they can access one key that's in their own pocket. Okay, total of 101 keys. Here's the deal. Any one of those 200 keys, right? We have 200 keys total. Any one of those 200 keys can be used at any time to encrypt data. Right? You take plain text and we want to encrypt it and turn it into ciphertext. I can take any one of those 200 keys and do that. But here's the deal. Once we have our ciphertext, once that data has been encrypted, there is only one key out of all 200 that can be used to decrypt the data, and that one key is whatever the matching paired key is to the one that was first used to encrypt the data. So, if so we'll say Ed has two keys with his name on it. If Ed encrypts data, if I take the key out of my pocket, my own private key, and I encrypt the data with that key, the only key that could then be used to decrypt it would be not that private key. I couldn't even use that same private key. I would have to go to my public key to then decrypt the data. Whereas if I were to encrypt the data with my public key, then the only key that could be used to decrypt the data, right, and turn it back into plain text, would be my private key, the matching paired key. At this point, hopefully this should be making a little bit more sense, but now you're probably feeling like you don't really understand why this is all in place. And some of it really doesn't make sense because it's like, well, if I encrypt with my private key and it could be decrypted with my public key, doesn't the public have access to it? That's not very secure. Okay, if that's how you're feeling, good. That's normal. Okay? I promise you, if you stick with me here, this is all going to come together in the end. So let's use a couple of very typical scenarios here, okay? First one here is we have a couple of people here. We have John and Mary, right? And you see they each have two keys, right? John has a private and a public key, and Mary has a private and a public key. John wants to send some secure data to Mary, right? John wants to send that secret note to Mary and doesn't want anyone else to be able to read it. So let's see how this works. John has this data, and he's going to encrypt it with Mary's public key, right? He's going to go to that box on the wall that everyone has access to, and he's going to take Mary's public key out of that box and then use that to encrypt the data, right? So we take Mary's public key, encrypt the data. John now can send that data to Mary, and it is secured, right? It's encrypted. And the reason it's secured is because once that data gets over to Mary, Mary can then decrypt the data and access it using her own private key. And who has access to Mary's private key? Only Mary. Okay, so Mary takes her own private key, decrypts the data, and goes ahead and accesses it. Whereas nobody else could have done that. Does that make sense? I mean, that's the most typical use of public key encryption. And that one usually makes sense to people. The part that doesn't make sense to people is this next scenario that I have here. And that is when you do what's called send authenticated data. See, This is the reason that we might actually encrypt something with our private key. The idea here is John wants to send something to Mary, and it doesn't have to necessarily be secured. He's not worried about the privacy of other people seeing this data. It's that he wants Mary to be able to validate and authenticate that it truly came from John and not from somebody who's claiming to be John. Right? Maybe somebody else claiming to be John sends something to Mary, and then Mary reads that and goes, what the heck is John saying that? That causes problems. So here's how the authenticated data process works. John takes some data and encrypts it with his own private key. So here's the scenario where John reaches in his pocket, takes out his own private key, and encrypts the data. Now, even though it's encrypted, is it really that secure? No, because what key would be used to decrypt the data? Well, John's public key. And who has access to John's public key? Everybody does. So it's not secure, but it is authenticated. And here's why. He's going to take that data that's been authenticated, send it over to Mary. Mary now gets this data and says, this is encrypted data, and it's telling me that the only way that, the only key out of all the keys that are in our environment that I can access this data with is John's public key. Right? So I go ahead and, or actually, I tell you what, rather than thinking of it that the data is telling her that it has to be John's public key, it says it's from John. That would be the better way of looking at this. Right? John sends it over to Mary. Mary sees there's some data here. It says it's from John, but it's encrypted. John says, so Mary says, okay, well, since it's from John, let me go grab John's public key. And I'll go grab that. And if I'm able to successfully decrypt the data with John's public key, that tells me it had to have been encrypted originally with John's private key. And who has access to John's private key? Only John. Therefore, Mary can validate and say, okay, this really came from John, not somebody pretending to be John. All right, so that's the basics. That's kind of public key encryption 101. And again, it's very generic, okay, very high level, but you need to understand this in order to truly understand how EFS works. Okay, because again, EFS uses both symmetric and public key encryption to secure the data. Now here's how it works. Step one, the file is, right, we have a piece of data, right, we'll say a file, and we want to encrypt it using EFS. So the first thing that happens is that file is encrypted using a symmetric key. Okay, so this is where it uses symmetric key encryption. This symmetric key is very often referred to as the FEK, F-E-K, standing for file encryption key. The next thing that happens is a copy of that FEK is made for the recovery agent. Okay, so that's something that I haven't really talked to you about, is with EFS, not only are we securing it for individual users, but we also always have what's called an EFS recovery agent, which is that one user on the network who can get into everybody's EFS encrypted stuff. And another thing about EFS, and this is the one thing that has slightly changed since its original inception back in Windows 2000, and that is originally EFS was made for just single users. Okay, so if I, Ed, want to encrypt stuff with EFS, it's going to be encrypted so that only I, Ed, can access it. And that's it. And the only other person that could get it is in case something happened to me, we'd have that recovery agent who was that one magical user who could get to everything. Now, I can explicitly assign other users who I want to allow the ability to access my data that I've encrypted with EFS. So I could explicitly say, the only people who will open this file are me, but then also John and Mary. I trust both of them. I'm going to let them get in as well. Well, in that case, the file encryption key, a copy of it is made for each person that I want to let in. So John gets a copy, Mary gets a copy, the recovery agent gets a copy, and then of course I still have a copy. The last step is that each copy is then encrypted, right? So we have, all these copies of the FEKs that are out there. Each one of those is independently encrypted using the respective public key for each of those users who need to be able to access the file, which means obviously the only way you're going to get back to that key is by using the private key, which is only held by the individual users. All right, I bet you're confused again. I know I would be. So I'll tell you what. Let's kind of illustrate an example here. This is where it's going to all come together. If you're still with me, and I know you are, because if you're hearing me say if you're still with me, that means you're still listening. And if you're still, like maybe the recording is still playing, but you've fallen asleep, pay attention. This is where it's all coming together. John has a file which needs to be secured so that only he can access it, other than wanting Mary to also have access to the file. Okay, so John wants to lock this thing down so that only he and Mary can get to the file. Here's everything that we need. Okay, we have the file itself. We have the FEC, right, the file encryption key. And then we also have, and actually I'll tell you what, there are 3 more keys. They'll come in later. Because John has a pair of keys, Mary has a pair of keys, and then there's the recovery agent who has a pair of keys. Here we go. Watch this. This is the cool stuff. John takes the file and he puts it in a box, right? We have this box. Put the file in the box. Once the file's in the box, you take that file encryption key and you lock the box. Now that's a symmetric key, which means the way you unlock this box is with that same file encryption key. So what we're going to do is we're going to make copies of that file encryption key and put one copy in a little box that's attached to the big, right? We got a big box with the file in it. We got 3 little boxes, one for each of the keys, right? One key is for John, one key is for Mary, and one key is for the recovery agent, because those are the only people who can access this EFS encrypted file. John is going to take his public key and he's going to lock one of those little boxes. He's going to take Mary's public key and lock one of the other boxes. He's going to take the recovery agent's public key and lock that other box. So now what do we have? We have 4 locked boxes. The big box on the right can only be unlocked with a file encryption key. But there are no file encryption keys available. Why? Because there's only 3 copies that exist anywhere in the world, and those 3 are sitting in those 3 little boxes over to the left of the big box. Those boxes are all locked. But here's the deal. Each one of those boxes was locked with a different public key. And when I say locked, we'll say encrypted, right? They were encrypted with the public key, which means the only way to get to it is by using a private key, right? The matching private key to get into those boxes. Now, real quick here, I should point out that there's an official name to these boxes. They're actually called fields that are attached to the file itself. And one is called the DDF, which is the data decryption field. In this case, we have 2 data decryption fields, and that's for the part where John's key is and then the one where Mary's key is. And then we have the DRF, which stands for data recovery field, which is the field where the recovery agent's key is. All right, let's see how this data is accessed. If John wants to go ahead and access this data or open up the file, this is where the private keys come into play. So John will reach into his pocket, take out his private key. He will unlock the little box that has a file encryption key in it that was locked with his public key, so he's allowed to do that. He'll then take out that file encryption key, and he will use it to unlock the big box, which then gets him access to the data. Now, if Mary wanted to access the data, you can see it would be the exact same process. I don't have it illustrated here for you, but it would be the exact same process, but Mary, instead of opening up the box that John opened up, she'd open the box next to it with her private key. Or if it came down to the recovery agent having to get in, the recovery agent would use their private key to open up their box to get the file encryption key to open up and see the data. All right, so that's how it actually works. So if you've ever used EFS, but you did it because you went into the operating system and you checked a little box and you said, cool, the stuff's locked, no one can get to it, it's safe. This is how it's safe. All right, so speaking of checking a box, why don't we go take a look and see how that works? Okay, so here we are over on a Windows Server 2012 computer. And I am on NYMem1, which, if you've been following along with the course, is a member server in the globalmantics.local domain, but that doesn't matter. Okay, it just completely doesn't matter. If you want to follow along, you can use any Windows Server 2012 computer you want. Matter of fact, you could even use Windows Server 2008, Windows Server 2003 or Windows 2000. You could use Windows 8, you could use Windows 7, you could use Windows XP or Windows 2000 Professional. Okay, there's a lot of options here when it comes to EFS, and it all pretty much works the same way. Okay, the bottom line is I'm going to go into my Windows Explorer, and if I jump over here, I'll go into Documents. That's fine, and let's create a new folder, and let's call it Secured Data. And inside there, we'll even create a new text document, and we're going to call that Secured Doc. All right, so now we have a folder and we got data in that folder. If I go to the properties of the folder, right here is an Advanced button. You click Advanced, and there's a checkbox, Encrypt Contents to Secure Data. And then you'll notice there's a Details button here, but it's grayed out, and it's grayed out because it is a folder. I'm going to show you this in just a moment. Click OK. Click OK again. Now it's asking me, you've chosen to make the following attribute changes. You want to encrypt. Do you want to apply these changes to this folder only, or do you want to apply it to any subfolders and files inside the folder as well? Well, let's go ahead and apply it to everything inside, right, all the way down through the hierarchy. So I'll click OK, and it was very quick because, well, let's be real. There was one blank document inside. All right. You'll notice something changed about this folder. The color. If you didn't notice it, it was black text before. Now it's green. There is a way to actually go in and change what color you use, I suppose, if you want. But basically, if you ever see that you have that green color on a folder or files when you go into a system, it means, if all the defaults have been kept in place, it means they've been encrypted. Which means the only people who are going to get into this folder, or really I should say the only person who's going to get in this folder is, well, the person who encrypted it, or the EFS recovery agent. If I go into the folder, you'll notice that the secured doc is also green. Why? Because I told it to encrypt everything inside. I might have said only encrypt this folder, but not the contents that are inside. So maybe any existing documents would have been left alone, and only the new stuff that I created, right? Meaning now that this folder has been encrypted, that means if I create another new folder, it's green. If I create another new document, it's green. Okay, because since this folder has already been encrypted, everything inside of it is going to be encrypted as well. Now if I go to the properties of a file, and again click Advanced, you'll notice the box is checked, Encrypt Contents to Secure Data. Now I can go to Details though. And in the Details, this is where I can add additional users who can access this file. So if I wanted to add, if I was John and I wanted to add Mary, I would click Add, and then go ahead and add whatever users you want to put in. Now I don't really have any users set up on our network here, right? This is just a very basic generic network. That's why I'm going to cancel out of it, and we just have the administrator. That's who I'm logged in as. And I can tell you that we could take this a step further, and I could create additional users. I could log off, log in as different users, and you'll see access denied messages by everybody else. But it's kind of anticlimactic. I think you can believe me that I'm telling you that by checking that box, that's how it works. Only I have access to it. When I go to open up a document, it opens. Someone else goes to open it, it doesn't open. But the very cool thing is, if the hard disk was stolen from this computer and put into another system, this data is still encrypted, and they're not going to get to it. Okay, so this is a great thing to do, let's say, on a laptop. Now, the only downside to that, if it was on a laptop, odds are they're not going to steal the hard drive from the laptop, they're going to steal the entire laptop. Then what you have to worry about is, can they hack into that laptop as the user? Because they won't, right? Meaning if they can't log in as the user who actually encrypted it, they're not getting to the data, right? They decide to take the hard drive out and move it somewhere else, not going to do them any good. But if they were to hack into the system and figure out the username and password and log in as that specific user, then yes, they're still going to get in. Okay, and then that would be something that you'd want to further encrypt, Okay, to protect against that, you want to use something called BitLocker. Okay, now BitLocker is something that we'll save for other lessons and or other courses, but I will tell you that BitLocker encryption is a way to take this a step further, even beyond EFS. But the bottom line is, you want to encrypt your data, use EFS. Gives you that added layer of security beyond your built-in NTFS and other types of built-in operating system permissions. All right, so that is pretty much how EFS works. I hope it became clear in the end. I know it's kind of a long, drawn-out process to have to go step by step. First learn what cryptography is, learn about keys, learn about symmetric versus asymmetric. Asymmetric or public key encryption is the difficult one. If I lost you anywhere along the way, I know from experience this is a typical lesson that people will go back and watch a second time, so don't feel bad about yourself if you have to go do it. I hope you don't. I hope I made it clear in one shot. But otherwise, that's all I got for you. So I will see you in the next lesson.